In the last lecture segment, we produced one rather uninteresting plot. We'll start this one by producing two uninteresting plots. But let's go through the code that produces them, because the code is at least a bit interesting. The first line of code is the same line we started the last program with. Pylab has a notion of a current figure. Executing a statement pylab.figure with some argument, let's say n, sets the current figure to the figure numbered n. Subsequently executed pylab commands implicitly refer to that figure until another pylab.figure command is executed. Therefore, the next line of code, pylab.plot, will draw some points and connect them with lines on figure 1, as we saw in the last segment. The next two lines begin by changing the figure to figure 2, a brand new figure, and then plotting some points on that figure. Now we see something we haven't yet seen, pylab.savefig. This function will save whatever the current figure is, in this case figure 2, into a file named, in this case, figureeric.png. PNG is the file extension. It stands for Portable Network Graphics Format. This is a public domain standard for representing images. We now go back to figure 1, draw some points on that, and then we'll save it in a different file, this one figure-grimson.png. If you look closely, you'll see there's something different about this pylab.plot command. I've only given it one list of values. Last time when we looked at this, we said we need to give it the x values and the y values in order to get points on a Cartesian plane. Here I've only given it one set of values. When you only give it one, it's the y values. The x values will then default, in this case, to range of whatever the length of the y values is. So here the x values will be 0, 1, 2, and 3. All right, let's look at the code and run it and see what happens. We're over here looking at the code in the idle window. We'll run it. Go over to the shell. Well, it's finished, but you'll notice no plot has appeared on my screen. Why is this? You may recall from the previous segment that in order to actually make the plot appear, we have to call pylab.show, which I did not do this time. However, if I go look under here, we'll see the folder in which I was running the program, and two figures have appeared in that folder. We can look at them, and we see figure.grimson up here, and figure-eric here. Nothing very interesting other than the fact that they exist. Let's look at a slightly more interesting example. The code we see here in the editing window is designed to show the magic of compound interest. Don't worry about the algorithm, it's pretty simple. It's what you would expect. Let's run it and look at the plot. Oh dear, we don't seem to have a plot. Well, what do we have instead? Well, instead we have a lot of red ink. If we come over here to our shell window, what we'll see is that there's an error in my code. And specifically, the dimensions of x and y are incompatible. Well, what does that mean? It seems to be a fairly obscure way of saying that the sequence of x values and the sequences of y values are not of the same length. Hence, it was unable to draw the plot. If we look at the code, well, we can see why. That I built y values with this loop, where I looked at range years plus 1. And I built the x values with this statement, simply years. So I have one fewer x value than y value. I can fix that. Let's run it now and hope we get a better looking, hope we get some plot at all. We do, and here it is. Well, what is this plot showing us? If we look at the code, we can deduce that this is a plot showing the growth of an initial investment. Well, let me show you the code, excuse me. If we look at the code, we can deduce that this is a plot showing the growth of an initial investment of $10,000 at an annually compounded interest rate of 5%, which would be astonishingly high in this day and age. However, if you just look at the plot, you can't really infer this. It could be a plot of almost anything. All plots, to be useful, need to have informative titles, and all axes should be labeled to tell us what the numbers actually stand for. So let's go and change our code to do that. First, let's insert a title. We do that with the command pylab.title. Takes a string as an argument. Next, let's label the x-axis. And finally, let's label the y-axis. Okay, let's see what happens when we run this revised code. Get rid of the old figure. And now we see I have a title, I have a X label, and I have a Y label. Now, anybody looking at the figure can tell what the story it's really trying to show. A couple more things I want to tell you about drawing plots, and then we'll move on to another topic for a while. For every plotted curve, there's an optional argument that's a format string, indicating the color of the curve to be plotted. The default color is blue. The format string for blue is B. That's why everything you've seen so far is blue. You can also indicate the line style. And the default for that is a solid line indicated by a dash or a minus sign. So we see that the default is B dash. And that is what we've seen. Suppose I don't like that default. Suppose I like red better than blue. Well, let's go back to the code here. I can go back to where I did the plot. And if I want, I can just put an R. And now if I do the plot, we see that the line is red. Well, suppose I don't want a line. Suppose I want to see individual points. I can type RO, or think of O as a circle, to see circles instead of a line. And now if I run it, I get the plot. It's also possible to change the type size and the line width used in plot. This can be done using keyword parameters in individual commands. Let's look at some code that does that. This code shows the growth of the principal as before, but I've now played around with some things. So for example, rather than using the default line width, I've set the line width to be 30. You might wonder, 30 what? That's 30 points. A point, for those of you who are not typographers, is 1/72 of an inch. For those of you who prefer metric measurements, I leave it to you to do the conversion. The next line, I've changed the pylab.title to set the font size of the title to 12 points, the font size of the X label to 6 points, and the font size of the Y label to a whopping 20 points. Not because I think this is artistic, but because it produces something that's quite bizarre and fun to look at. I don't recommend that any of you produce plots that look like this, at least not if you want to get a nice grade on them. If you get tired of changing these things in the code, it's possible to change the default values. The default values are stored in something called a .rc file. YRC? It's derived from the .rc file extension used for runtime configuration files in the Unix operating system. I'm not going to go through changing the RC settings now. If you want to see how to do it, you can look it up in the text, or you can look it up on the online references we pointed to in the previous segment.